We're back for another series of videos, this time on logical routing within NSX. If you're following along in order, we've talked through the NSX Manager and what it is and what it does. We've talked through how to deploy the managers and how to prepare the data plane. We even mentioned DPUs and smart NICs and that kind of stuff. We've then talked all the way through logical switching, what it is, what they are, what they do, how we build them, all that kind of stuff. Well, if I've got more than one segment configured, I probably need a router between them, and that's where logical routing comes into play. It's not the only place it comes into play, naturally. I can interconnect two segments, and I can connect my NSX domain to the outside network, right, to the non-NSX network in my data center. And that's really what we're looking at, is how we build out the layer 3 infrastructure now that we're building our layer 2 infrastructure with logical switches and segments. Now, this is a big topic. There are going to be a bunch of videos that we go through here. We're going to talk through the overview here. We're going to talk through the edge nodes and edge clusters. We're going to talk through the gateways themselves, tier 0 and tier 1. We're going to sort of introduce those here, but we're going to go into detail a bit more later on. We're going to talk about static routing. We're going to talk about dynamic routing with BGP and OSPF. We're going to talk about equal cost multipathing and high availability. We're going to kind of walk through how packets move through all these different components in NSX. And then finally, we're going to wrap things up with a brief discussion on VRF Lite in NSX, or the ability to kind of take those tier 0 gateways and subdivide them a little bit. That's kind of what we're looking for. So there's your sneak peek of this series of videos about NSX logical routing. Now, where are we going to start? We're going to start with an overview, of course. And this is going to kind of help us understand what logical routing is, what it's going to do, what are the components and moving pieces that we're working with, and interfaces and things along those lines. So there's still a lot of stuff here. There are a number of moving parts that we're going to think about. Now, we talk about use cases for logical routing, and everything really distills down to a single point. I need a router connected to my different segments to move packets between them, right? The same reason I would have a physical router is to sit between networks and route packets between them. Now, that can be explored in a number of different contexts, whether it's multi-tenancy, whether it's simple separation of production and development domains or things like that, whether it's simply I want to do some routing. Logical routing allows us to do kind of some localized routing, so maybe I don't have to send packets all the way out to a physical router to do their thing. So there are a number of reasons that we want to use logical routing if we explore the core function a little bit. Now, in order for us to have logical routers, in order for us to build logical routers, we need basically the stuff that we've worked on up to this point. Again, if you're following along in order, everything we've done to this point. I need my managers deployed. My cluster needs to be there. My hosts need to be prepared as transport nodes. I'm also going to need to deploy edge transport nodes. We're going to need probably some logical switches, although, that's not 100% necessary. It's likely, and that means we're going to need transport zones and transport node profiles and all that kind of stuff. Now, in NSX, we're going to have different logical routing to support different needs, right? We have centralized north-south routing. We have distributed east-west routing. And as we start talking about things like directions, right? East-west routing is really inside of our NSX domain, from segment to segment, perhaps. North-south routing would be into and out of the NSX domain. So from NSX out to your physical network or back in. That's kind of how we approach north-south and east-west. we can do some of that routing, particularly the north-south routing. We can define different paths, either statically or dynamically. We can provide for multi-tenancy. We have highly available routing components. We'll talk about some of that. We can support IPv6. We can support multicast routing. There's a lot of cool stuff that we can and in many cases will do with NSX logical routing. Now, as we think about logical routing, we think about the things that we're doing, the things that are going on, we're getting into different types of gateways. Now, gateways are policy objects that represent logical routers and their desired states. And we've got two different types of gateways to work with. We have a tier 0 gateway and a tier 1 gateway. The simple way to discriminate between them is that a tier 0 gateway is kind of my provider router, right? This is my infrastructure router in NSX, where my tier 1 gateway is kind of my tenant boundary or my environmental boundary or my organizational boundary. I'm going to have fewer, well, not necessarily, but likely going to have fewer tier 0 gateways than I am tier 1 gateways. And I may use tier 1 gateways for a great many things. Now, there are other differences. Tier 0 gateways can run a BGP or an OSPF process. Listen to me smash those together. Can support dynamic routing processes where a tier 1 gateway is statically programmed either both by you through static routes and by the NSX system from the central control plane. So there's no dynamic routing on a tier 1 gateway. And that's not as big a deal as it may sound. We're just wait till we explore how all this comes together. The tier 0 gateway is designed and intended and implemented as that north-south connectivity, that connectivity between the NSX domain and the physical router. So it's going to have uplink interfaces to connect to the outside world. The tier 1 gateway is going to connect to my segments, and it's going to connect to a tier 0 gateway, right? So it's intended to exist strictly inside the NSX domain and move packets north to the tier 0 gateway to get them out. The tier 0 gateway will always be associated with an edge cluster. The tier 1 gateway may or may not be associated with an edge cluster. So there are a number of differences to these different gateways, and we need to talk about how we're going to use them, to their best purpose. Now, that's what this module is all about. That's what this series is going to help us understand. So if it doesn't quite make sense yet, hang on to that. We're gonna keep going with this. Now, because we've got different gateways, we can deploy things in different topologies. And the tier 0 gateway really has a little bit more flexibility because it can also attach to segments as well as the physical infrastructure. So I could build a single tier network topology like this. Chances are we're going to have a multi-tier topology, but a single tier is certainly plausible. This is a reasonable topology if this meets my needs. In most cases, however, the multi-tier topology is what's going to meet more of our needs, not because we want more routers. That's certainly not the case, but that's what we're going to end up with, a tier 0 gateway to connect us to the outside world, and then tier 1 gateways for whatever my different environments are, however I'm organizing my network. We're going to have this, one, because it gives me that organizational boundary, that layer 3 domain boundary for each tenant, business unit, application group, whatever it is. And it also gives me a place to run, very specific services. Part of the spirit of NSX is to allow us to implement network services right with the applications that require them in a very distributed fashion. Well, being able to have all of these different tier 1 gateways allows me to kind of distribute those services, whether it's NAT or a VPN or whatever else it might be. Advanced security services, perhaps. And that's a big thing, especially as we move into some of the security modules and talk about some of the security things that NSX does. Our advanced threat prevention largely happens, at least from a north-south perspective, on that tier 1 gateway, and we don't implement those services on a tier 0 gateway. So there are a lot of reasons we may choose to deploy tier 1 gateways. Now, those routing services and those other network services require compute resources, right? A VPN has to be able to encrypt traffic, and it's got to do that with compute resources that we collect from somewhere. Well, that somewhere is going to be an edge node, right? An edge node is a transport node that we're going to deploy. It's probably going to be a virtual machine. It could also be a bare metal. We'll talk about that. But the edge node is where my centralized routing and network services components are going to be realized, because that edge node, that virtual machine or that physical machine, is going to have compute resources available for us. Now, we're not going to consume edge nodes directly. We're going to consume edge nodes by way of an edge cluster. In other words, we're going to consume this cluster object, and this edge cluster is going to be made up of one or more edge nodes, and that's going to give us capabilities of things like high availability and load distribution and all kinds of fun things there. As we're looking at uplinks and connecting these tier 0 gateways to the physical routers, right? I've got to have the tier 0 gateway as a router. It's got layer 3 interfaces. The layer 3 interfaces that face the physical network are called uplink interfaces. I've got a couple of different ways I can approach uplink interfaces. Now, an uplink interface is going to live on an edge node, and it's going to be associated with a specific edge node in an edge cluster. And so this is where some of the traffic distribution can start to come into play. I can set up my infrastructure such that each edge node has a single uplink. Typically, that's going to be in cases like we're showing here on the left-hand diagram, where we have a shared transit VLAN, right? Both of my uplink interfaces on my tier 0 gateway are part of the same VLAN. Both of the interfaces on my upstream physical routers are part of VLAN 100 here, and everybody's on a common transit VLAN. This could be how my topology is set up. However, I may set up point-to-point transit VLANs like we're doing on the right-hand side, where I have VLANs 100 and 300 attached to tier 0 gateway on edge node 1, and VLANs 200 and 400 attached to the tier 0 gateway implementation on edge node 2. Now, the uplinks, the 4 uplinks that we're showing here, these are not part of different gateways, right? These are all 4 uplinks on a single tier 0 gateway that's distributed across multiple edge nodes in an edge cluster. But I can do point-to-point transit networks, or I can do a shared transit network, whichever way is appropriate for my particular infrastructure. Now, what else do we want to look at or think about with these gateways? Here we go with more components, more moving pieces. Each gateway is going to have a DR component, a distributed router component. And the distributed router component is going to be realized on each individual transport node. Right? Every single transport node is going to have a copy of this DR. And this is going to provide typically first hop routing. It's going to provide routing from a static forwarding table. We're going to grab the packet at the source, and we're going to look at where it needs to go and forward it on from there. Now, some of my gateways, my tier 0 gateways in particular, but perhaps many of my tier 1 gateways are also going to have a second component to them called an SR, or a service router. And that service router is the centralized component realized on an edge transport node, and only on an edge transport node. And this is where I'm going to get the compute resources to provide NAT services or VPN services or things of that nature. These are not separate objects. Well, they're separate objects. They're not separate. What's a good way to put it? These are two sides of a coin. That's a good way of putting it, right? A gateway will have both of these pieces. All right, one of them may or may not be realized, but a gateway will have both of these pieces. And so, don't think about the individual DR or SR components. Think about the gateway itself. right? Think about the gateway itself. The service router provides the centralized capabilities. The distributed router, as the name implies, is the component that provides the distributed capabilities for any given gateway, either tier 0 or tier 1. And so here we're just showing tier 0 or tier 1. We can have the DR and the SR components. Now, how are these realized? Well, the DR component is scattered across every transport node in the infrastructure. It's everywhere. Everything in the transport zone has this DR component for whichever gateway this is. And then the service router components, the SRs, those are only realized on edge transport nodes. So let's look at this a little bit of a different way. And we're still looking at DR and SR components. We're thinking about where they're realized and how they're going to be realized. So here I have a single tier routed topology. If we look at the logical view diagram on the left, I have a single tier 0 gateway that, due to the components I have in my infrastructure, I have 2 service router components, which tells me I have 2 edge nodes, and I have an uplink on each edge node here. So I have service router 1 and service router 2. These are both part of my tier 0 gateway. And that tier 0 gateway is downlinked to 2 different overlay segments, segment A and segment B. Well, if we look at the physical view here, we see the ESXi hosts, my transport nodes, and whether we have 2 transport nodes or 200 transport nodes, it makes no difference. We can run with this example. My edge nodes, right? My edge nodes have my different service router components on them. And if we look at the distributed router component here, notice how we've got this hashed line that kind of squares across and crosses my edge nodes in my edge cluster and crosses my ESXi hosts. What that's there to represent is that the DR component is realized on edge node 1, and edge node 2, and ESXi1 and ESXi2. All 4 of these transport nodes have a copy of DR T0GW. Right? They all 4 have a copy of this. And so that DR is going to behave exactly the same no matter which transport node we're looking at. Right? Service router 1 and service router 2, well, those are the components that own uplink 1 and uplink 2. And because of that, they're centralized to one edge node or another. Now, if we make this a little more complex and we add 2 tier 1 gateways to the mix. So we still have our tier 0 gateway. We still have our 2 edge nodes with service routers. We still have a distributed router for the tier 0 gateway. Then we go into the 2 tier 1 gateways, tier 1 gateway A and tier 1 gateway B, right? Those 2 gateways have the overlay segments attached to them. And if we look at the physical diagram, we can look at and see the same things we just saw for our single tier 0 gateway. We have service router 1 on edge node 1 with uplink 1. We have service router 2 on edge node 2 associated with uplink 2. Those centralized resources are exactly where they were in the last diagram. The distributed router for the tier 0 gateway is also distributed across all of my transport nodes. But here we've added in 2 different tier 1 gateways. These tier 1 gateways are not associated with edge clusters, and therefore they only have distributed router components. In that scenario, well, what do we have? We have 3 different distributed routers. We've got a distributed router for the tier 0 gateway. We have a distributed router for tier 1 gateway A and a distributed router for tier 1 gateway B. Now, these are all interconnected. Tells me they're all part of the same transport zone. So what are we looking at? We're looking at all of these different objects being distributed across all of the same transport nodes. So I could look at ESXi1 and I could see 3 different DR components realized. Now, if we complicate this just a little bit more and associate tier 1 gateway A and tier 1 gateway B with the edge cluster, well, that means that those devices both are going to end up with a service router. And if we look at that, right, my service routers are populated across my different edge nodes. My tier 0 gateway realization really hasn't changed, at least not from a service router perspective. But if we notice, if we look closely, the DR for Tier 0 gateway is only realized on Edge Node 1 and Edge Node 2. Well, it's happened because the natural packet flow for these Tier 1 gateways is to send a packet from the Tier 1 distributed router north to the Tier 1 service router, then up to the Tier 0 gateway, right? If we follow the path logically, which means that we're never going to use the DR component for the Tier 0 gateway on any of the hypervisors. So we don't realize that DR there, right? We don't need to worry about it there. We just need to worry about it on the edge nodes. The DR components for the Tier 1 gateways, however, those are realized across all of the transport nodes because they're providing the gateway services for our virtual machines. Now, gateways have a number of different types of interfaces, and we've kind of seen some of those as we've built through some of this material in this video. We've seen our uplink interfaces, for example, on our Tier 0 gateways. We've seen, but not called them out as, downlink interfaces attaching my gateways to segments. Now, a downlink interface, sure, our diagram here only shows the downlink interface on a Tier 1 gateway, but my Tier 0 gateway can also have downlink interfaces. That's how I enable my single tier routing topology. Downlink interfaces are what we use to connect gateways to overlay segments. Right? We've got another type of interface called a service interface. And a service interface is typically used to connect a Tier 0 or a Tier 1 gateway to a VLAN interface or a VLAN network. Right? So a downlink is used for overlay networks, and service interfaces are typically used for VLAN networks. We've got a connection from the DR to the SR, right? Those are two different components, but we're not using anything proprietary to move packets between the DR and the SR components. We have an intra-tier transit link that we're going to create. Now, this is going to be automatically plumbed and created when you build the gateway or when you associate the gateway with an edge cluster and get that service router component. We also have a router link network, which is a Tier 0 to Tier 1 transit network. This is another overlay network that's automatically created when I link a Tier 0 gateway to a Tier 1 gateway. So we've got a number of different interface types that we may have to look at. So I know that's a lot to start with. We saw there's a whole lot going on in this module in this series of videos. So here we just kind of scratched the surface. We laid out multi-tier routing. We laid out single-tier routing. We laid out the distributed and service router components, and we laid out our Tier 0 and Tier 1 gateways. We talked about our interfaces. So we covered the basics here, right? Real high-level view. As we continue to move through, we're going to make sure we go into much more detail on all of these different things, and we'll start to see how they all come together. So stay tuned. There's more where this came from. We'll see you in the next video.